All right, after that last one with a lot of theory behind it and getting your formulas, let's get into some useful games, huh? Let's use your time wisely so you can dominate your homework. All right. Well, we learned our Pythagorean identities, and really let's keep our focus on sine squared plus cosine squared equals 1. We have a couple others, but let's just wait on it a little bit, okay? So we want to, here's an example of a problem that you have. I actually took, the wording's a little different, but it's the same thing from your homework problems. You have a couple of them. It's like your 6th and 7th problem in 1.3. And it's going to ask you to do this. And I want to show you that you have options. You got a couple options, just to know that they're there, and then you choose what works best for you and let the other one slide. Now we could use our identities, or we can make a triangle. And I'm always a fan of making a triangle, because this question is asking us to find the remaining 5 trig functions, given that the angle is an angle of a right triangle. That theta is an angle of a right triangle. Okay. So really, intrig. Bruh. Draw a triangle. Anytime you don't know what to do, draw a right triangle. I shit you not, it is amazing. You have not even started trying to do the problem until you draw a damn right triangle. Just draw a right triangle. Put an angle somewhere. I'm going to put theta there. Now, can you figure out? Now, my shit will not be to scale. It's not even going to be close. I don't give a crap as long as things are placed in the right spot. I go, dude, cosine, isn't that the adjacent? That 8, and then the denominator, isn't that the hypotenuse? So we're like, oh shit, well look at there. Oh, there's the hypotenuse. There's the adjacent. Well shoot, now all we gotta do is just give it some sort of name. Like, be like, this one over there is B. So you have a squared plus b squared equals c squared. So you just go solve for b, and now you got a triangle when you look at it. We're right back to where we were. I think this is the best method. If you want to go solve one of these, I give you cosine of theta equals this, or I give you tangent, or I give you secant, and I tell you it's just a right triangle. Dude, I think this is the best way of going about it. So, let's go get it. Let's finish this one up, and then we'll go back and we'll use our Pythagorean identities and see that way is a very valid method as well. And you might prefer it. So, let's go. So we have a squared, so that's 8 squared, plus that b squared is going to be equal to 17 squared, so we're putting that variable right there. Okay, b squared. Now, I would learn this one. I'm giving you what's called Pythagorean triples right now. They work out really nicely. I'm just going to run it real fast. That's 289. B squared is equal to 225. I've done these 1,000 times, so I know them. And then if you hit them both with a square root, you're going to find out a square root of 225 is 15. So we went and we found our b to be 15. Yeah, so there's our b. We can actually just lose the fact that it says b and leave it with 15. Now, bang. I think it's not too bad to go find our 5 remaining trigonometric functions. Okay. So let's write in our answers now. We'll be like, all right, well, sine of theta is that opposite over that, so 15 over 17. Cosine of theta was given in the damn problem. I like to write it down the same way every time, and then I go tangent. And let's play I don't even want to look at the triangle. Isn't that just going to be 15 over 8? Look at the triangle, 15 over 8. Ah, look, it's just the numerators of sine and cosine. 15 over 8. Sweet. And now we just play the game that cosecant goes with sine, and we just flip that shit over. It's 17 over 15. Yeah, it's hypotenuse over opposite, by the way. Secant of theta, we just flip over cosine. That's going to be 17 over 8. And that's the hypotenuse over the adjacent. So it's always bigger than 1. Or 1 or bigger, actually. And then cotangent of theta, we'll just flip over OA, huh? Make it AO or something. 8 over 15. Look at that. That's a fun game. I like testing on that game, too. Because you just got to be solid with it. Solve a damn triangle? Come on, let's go. Let's go. Okay, here's the other method. You don't make a right triangle. You just use identities. I think you should always make a freaking triangle. So if we have that cosine of theta is equal to 8 over 17, let's go use our Pythagorean identities to go do some work. So since we know that sine squared plus cosine squared is equal to 1, we can go through and replace our cosine. What I like about this is this helps us to see where things are. Like how we write that word, cosine squared, that shit's weird. So why don't we do that and bring the square on the outside? And we go, whatever cosine might have been, whatever it equals means it is, and we change it to 8 over 17. And now we can solve for sine. And I'm guessing most of y'all are looking at this going, this sucks. This sucks. I don't like this. I got to square a fraction. Holy shit. If you're going to be a STEM major, you better get used to this stuff. May not like it now, but it's okay. You'll get to it. So 8 squared is 64. 17 squared is 289. I swear I've seen these numbers somewhere before. Is equal to 1. Well, we're going to need to get this number. We need to get it over to that other side. So we're going to need to change 1. Come on. Let's make a common denominator that's going to work with 289. So you know what you do with 1? It's 289 over 289. Now subtract that thing over. You're actually doing all the same math you did in the right below in the other problem. It just looks different because we have fractions. So 289 minus 64, that's actually 225. So 225 over 289. Right, so that's 289 over 289 minus 64 over 289. So it's actually looking more like this. All right, common denominator. So you just do 289 minus 64. It's 225. You got that common denominator. It's 289. Hit it with a square root on both sides. Since we're dealing with a right triangle, everything is going to be positive. We have no worries. The square root of 225 is 15. The square root of 289 is equal to 17. And we went through and found sine. Does that match up? Does that match up? Oh, no shit. It matches up. We got that from back here. It was just another method for us to go get sine. Well, once we're here, once you have sine and cosine, you have everything. Once you have sine is equal to 15 over 17, and that you have cosine is equal to 8 over 17, I don't need to make a triangle anymore. Remember that game with tangent? Tangent is just the numerators, right? So we'd say it's 15 over 8. Once we're there, once you have sine, cosine, and tangent, we're freaking done. So cosecant, again, you just flip it over. And that's the method without ever making a right triangle. I don't like that way. Like, I feel pretty solid with it, but I don't even do it that way. But it does help you to see, like, I really do like the notation piece of you looking and seeing what sine squared and what cosine squared actually means and how to plug things into it. Because that shit's weird, and we're going to make this, and I want you to play with that before you go to a test. Before you're forced to do this, I want you to see and explore and see the pitfalls. All right. So there's our game. Just wanted to show you. So you have a couple problems in your homework that are just like this. So I thought I would do one that's very similar. And the next, I'll play one of the next games that you're going to find in your homework that might be just a little bit tricky, and we'll go through and kind of clarify some stuff. So see you then.